The city's rhythm comes to life as the sun rises, accompanied by a gentle breeze. After the YuanShanTzi flood diversion works for the Keelung River were completed, the problem of flooding was resolved, and the Shizhi district, with its close proximity to Taipei City, became an attractive area to live in. This was the beginning of a new era of prosperity for the city. One of the three main tributaries of the Danshui River, the Keelung River originates in Jingtong Mountain in Pingxi District of New Taipei City. With a catchment area of 491 square kilometers, the river's course is winding and gentle, like the body of a coiled dragon. It passes through Ruifang, Qidu, Shizhi, Nehu, and Nangang, and then finally flows into the Danshui River at Guandu in Taipei City. The many changes of terrain along the Keelung River have supported a diverse array of culture along its shores. It is one of the most important bodies of water in Taiwan in terms of nurturing the special cultural characteristics of the northern Taiwan. The wild beauty of the Keelung River has created some amazingly beautiful natural scenery. However, it is always at risk of flooding, causing an unpreventable disaster for the people who live in the low-lying areas along its shores. From 1996 to 2001, typhoons going by the names of Herb, Zap, Babs, Shangshan, and Neri hit Taiwan in succession, and they all caused serious flooding on both shores of the Keelung River. Typhoon Neri caused particularly serious flooding, with a flood range that basically covered the entire Keelung River basin. The flood depth was more than 8 meters, and the flooded area was more than 4,800 hectares, that even the Taipei metro area was spared, in addition to taking 104 lives and flooding about 30,000 homes. The property damage caused by the flood reached 15.4 billion NT dollars. There is an astonishing amount of annual rainfall in the mountain valleys upstream of the Keelung River. With many successive rainstorms, the concentrated runoff makes for a deep and fast river flow, though the river course becomes gentler downstream. The flat land along the shore is narrow and low-lying. The tidal reach of the river is very long, leading to backflooding easily in Shizhi during typhoon season. Therefore, the floodwaters have nowhere to flow to. In recent years, urban development has struggled to take land from the river, which has made the river's course narrower. This has provided less room for floodwaters to recede, causing ever worse flooding. With the fervent support of local governments and residents, regulation of the Keelung River has become a top government priority. The Executive Yuan led the way in 1998, by approving 12.18 billion NT dollars of funding for a 2-year Keelung River training works preliminary implementation plan. This involved revetment building and dredging on both shores along a 22.8 kilometer section from the Nanhu Bridge to the Badu Railway Bridge. This protected the low-lying areas along the shore from decennial major flooding, and it was a good overall foundation for the future governance. The effects of Typhoon Shangshan and Typhoon Neri, which hit Taiwan in October 2000 and September 2001, respectively, were especially devastating. The government showed its determination for river regulation by instructing the River Resources Agency to speed up implementation of the portions of the preliminary river training plan that were the most effective with the least damage to the environment and of the most pressing need. The plan was implemented over 3 years from July 2002 to June 2005, with a total investment of 31.62 billion NT dollars. In this process, the building of YuanShanTzi flood diversion channel was determined to be the most effective in limiting the height of flood waters. Therefore, this project was given priority. The main purpose of the YuanShanTzi flood diversion works is to divert the Keelung River's floodwaters from the 91 square kilometers upstream catchment area at Shinchun in New Taipei City's Ruifang district through a flood diversion tunnel past the west side of Keelung Mountain to an area 1.8 kilometers east of Provincial Highway No. 2, near Shen Outport and into the ocean. This is a water-related tunnel project of a scale that had never been seen before in Taiwan. Work began on June 5, 2002. To shorten the work period so that the disaster prevention effect could come into play as soon as possible, the package bidding method was used to combine the construction work with the detailed design work. The main project budget was 4.28 billion NT dollars, and the flood diversion level designed was for a 200-year flood crest to meet the objective of protecting against the flood level that occurred during Typhoon Neri. Besides maintaining the basic flow level of 310 cubic meters per second, the benefit of downstream water users, the river ecology, water purification, and the maximum flood discharge was designed as 1,310 cubic meters per second. The infrastructure works included the excavation of a flood diversion tunnel with a diameter of 12 meters, a length of 2.48 kilometers, and a slope of 1%. In addition, an 8 meters high and 30 meters long diversion weir was built at the water inlet area. They also built a 184-meter side flow weir at the right side of the upstream section. A stilling basin was also built at the tunnel inlet to reduce the amount of sand flowing into the tunnel. 3 slit-type check dams were built upstream from the diversion weir to block large timber and rocks and prevent impact damage to the flood diversion facilities. The water outlet section was built to go underneath Provincial Highway No. 2. A graduated chute section and an energy dissipator were built at the headland defense works. The energy dissipator is 120 meters long and 35 meters wide. A 10-meter water cushion is maintained there. It can fully absorb the energy of the water flow to reduce the impact of the flood diversion on the coastal environment. The innovative part of this engineering object was the use of natural flood diversion design with an unmanned operation. Before construction, to ensure an accurate understanding of actual operations, waterworks modeling was used to verify the flood diversion flow through simulation. This allowed for the adjustment of flood diversion routes and inlet and outlet structural configuration. A diversion pier was also added to the flood diversion weir, and the partition wall was built at the water outlet to ensure that the flood diversion function was achieved. In addition, when the flood discharge reaches 1,310 cubic meters per second, the speed will be 17 meters per second. Therefore, the project specially used 450 kilogram square centimeters Fernand slag concrete to resist the wear and tear by the fast water on the waterworks structures. Additionally, because the design flood diversion amount was so high, the profile of the flood diversion tunnel inlet and outlet structures had to be expanded to 350 square meters, so the sufficient structural strength and channel profile could be provided for discharging the flood waters. At that time, the progress of the flood diversion project faced a serious test. The work schedule was tight, and the construction area had a large annual amount of rainfall, so work had to be done in the river during flood control season. In addition, the geological conditions in the area where the tunnel passed through were not ideal. The construction team did additional pre-excavation geological survey work, and the length of the test bore was made 1.3 times longer than the tunnel length. To help the work progress more rapidly, faster work methods were used for the key project to meet the goal of using 100 million NT dollars in project expenses each month, so the tunnel could be completed within 1 year. In addition, concerning the social opposition to diverting flood waters through a tunnel, the construction team held public meetings to respond sincerely to the opinions of residents and to ask for public support for the sake of a win-win situation for the government and local residents. With proactive efforts from everyone involved, the YuanShanTzi flood diversion works were successfully completed on October 28, 2005. The construction team overcame the difficulties posed by faults, abandoned mine pits, and shallow underground streams, and properly controlled the project costs, progress, safety, and quality. After the tunnel was opened, but before the tunnel lining was completed, they properly prepared for emergency flood diversion. They successfully completed advanced flood diversion 4 times in the flood control season from 2004 to 2005, effectively preventing downstream flooding. They were awarded the special honor of the 6th Public Works Gold Medal Award. The YuanShanTzi Flood Diversion Administration Center, located near the banks of the Keelung River downstream from the water inlet diversion weir, is responsible for the maintenance, management, and operations of the flood diversion facilities. The entire flood diversion facilities are operated using an automated monitoring system, including hydrological measurements and flood diversion alarms. A real-time water condition information collection and inspection system integrates real-time water level imaging information from the flood diversion channel and the diversion weir for flood diversion operations. It can measure water information to be provided to the Danshui River Basin Flood Prevention and Control Center and related local government as a basis for decision-making. The center is usually manned by 4 people who inspect and maintain diversion weir, the flood diversion weir, the water inlet structure, the flood diversion tunnel, the water outlet structure, and the sand discharge channel gate, and who make flood diversion measurement, records, and safety inspection reports. They also maintain the check dams, the areas upstream and downstream of the diversion weir, including the fishway, the flood diversion stilling basin, energy dissipator, and flood diversion tunnel, and do settlement removal work. Another of their important duties is public outreach and education. During the typhoon and flood seasons, they cooperate with the Danshui River Basin Flood Prevention Control Center, and the Deputy Chief lead personnel to go to the Administration Center when there is a Category 2 typhoon or higher. The center is then responsible for opening and closing the sand discharge channel gate, measuring and reporting water levels, water flow, and imaging information, safety inspection of the tunnel structure and slopes around the inlet outlet, and emergency handling. During flood diversion operations, the sand discharge channel gate is closed. Usually, the sand discharge channel is kept fully open, which is beneficial for the discharge of sediment from stilling basin, and it effectively regulates the river's flow and reduces the ratio of the frequency of regular flood diversion to flood diversion volume. Project used natural overflow flood diversion with the weir built at the main course of the Keelung River to block water flow. There are drain holes in only 2 places to maintain the basic flow of the river. The elevation of 63.0 meters at the top of the flood diversion weir is the flood diversion threshold. When the water level of the upstream Keelung River exceeds this threshold, the flood water will naturally overflow over the flood diversion weir into the tunnel. During flood diversion operations, the Danshui River Basin Flood Prevention Control Center receives reports from each stage. When the water level upstream from the diversion weir reaches 62.5 meters, the flood diversion early warning alarm will sound. When the water level at the top of the flood diversion weir reaches 63.0 meters, the flood diversion alarm will sound. During emergency flood diversion, the gate is opened for emergency drainage according to the emergency handling plan, thus regulating the flood diversion volume. The water level at the top of the flood diversion weir has reached 67.2 meters, and the tunnel will be filled with water. Issue the emergency alarm. Implement emergency flood diversion. The YuanShanTzi flood diversion works effectively control the peak flood level for Huashaoliao, the area in Taiwan with the greatest amount of rainstorms, and 18.5% of the whole catchment area upstream from the flood diversion weir. According to flood diversion statistics, the water level at the section of the river in the Ruifang district has dropped by 3.13 meters, and the water level of the section of the river in Keelung City has dropped by 2.2 meters. In Shizhi district, the area that had been seen hit by the worst flood in the past, the water level of the river has dropped by 1.5 meters. The flood diversion works also combine with upstream water and soil conservation work and downstream flood control area levee construction to allow New Taipei City and the Keelung City in the upstream and midstream sections of the river to achieve flood control standards that protect against 200-year flood crests and to reduce the area of flooding by 1,321 hectares. In addition, the regulation plan for the downstream section of the river can proceed without removing housing from the banks of the river, thanks to the flood diversion works. That reduced the budget for acquiring land by more than 30 billion NT dollars and could save on river regulation expenses of reducing the height of levees and rebuilding bridges. A significant benefit was also realized in boosting the disaster prevention measures for protecting neighboring areas, lowering the impact of urban development and traffic, providing high-quality riverside recreation areas and safe environments, and enhancing land use. The public no longer needs to worry about flooding. The quality of life and environment of the region have been improved. The residents can feel an increased sense of safety. Therefore, the industrial, economic, and business development of the downstream area of Keelung, Shizhi, Nehu, and Nangang have been boosted, earning high praise from all walks of life, while the number of people moving into these areas is gradually increasing. When visiting the upstream section of the Keelung River today, one is presented with a beautiful river vista, which is the result of the river regulation work. Upstream of the Sterling Basin, flocks of white egrets forage for food. In the direction of Hotong, where rocks and various sizes are scattered across the riverbed, rare geological formations called potholes can be seen. Following the river, there are areas which were prosperous during the era of mining, such as Ruifang District, Jiufen, Jinguashi, Pingxi, and Hotong. This area has seen the development of the tourism industry thanks to its fascinating cultural features such as the famous sky lanterns, the Shenkeng River Iron Bridge, and buildings left behind from the era of Japanese rule. Flood control works are essential infrastructure for national security and economic development. The development of waterworks technology has allowed us to find a solution for living in harmony with water as we deal with flood and drought control in the face of extreme climate change. The YuanShanTzi flood diversion works protect the people living along the Keelung River so that living and working in peace and happiness is no longer just a slogan, but a blessing that has appeared in the midst of our lives.